So when we talk about half-lives and radioactive decay, we also have to talk about exponential decay. So this means that you're going to have kind of a curved decreasing graph. So half of the material will be left at the end of the first half-life. But then in the same amount of time after that first half-life, you're going to have only a fourth of that material left. And then after the third half-life, it'll only have 1/8 of that material. Okay, so you get a graph that looks like this. Okay, where you start off with 100% of your material is, in this example, carbon-14. Okay, and then you pass through the half-life, the first half-life. And at that time, half of what you had is now going to be nitrogen-14. Okay, so we started out with 8 carbon-14 atoms, and now we have 4 left. So we have half of what we started with. And then you go through the second half-life. Okay, now you're going to lose half of what you still had of carbon-14. So you had 4, now you have 2. You go through the third half-life, and you lose half of what you have left. You had 2 here, so now you have 1. And after the fourth half-life, generally it's down to 0, in this example at least. Okay, now if you had more atoms of carbon-14, you could continue going for quite a few half-lives. Okay, so just keep going. And it just keeps approaching 0. At some point, really depending on how much you start off with, you will eventually reach 0. Okay, but it takes a while. Okay, all right. Carbon-14. So talking about carbon-14 in particular, it is used to date organic materials. Okay, so basically figure out when they were created. Okay, so this is done because carbon is found in all living material, all organic material. Okay, and it's used to date any organic material such as fibers from ancient clothing, animal remains, human remains, bones, different bacteria can sometimes be the case. You know, a lot of different things, okay? Fossils, things like that. Yeah, little joke here. Carbon dating. Haha. Anyway, so a small amount of carbon contained in any organic material is carbon-14, which is radioactive. Remember, it has a half-life of almost 6,000 years. Okay, so it's not an issue that you have carbon-14 in your body right now. Everybody does. It's a low-level background level of radiation. So it's not an issue. Okay? When the organism is alive, that carbon-14 concentration remains constant. And that's because you're still eating food, you're replenishing your carbon stores. Okay, so you're getting a relatively constant level of carbon-14 in your body. Okay, but when an organism dies, that carbon-14 concentration begins to decrease due to beta decay. Now, this isn't saying that the carbon-14 in a living organism is not undergoing beta decay, because it is. It's just getting constantly replenished. So as the carbon-14 decays into nitrogen-14, then you eat something and you get more carbon-14. Okay? Now, when you die, you're no longer eating anything, so that carbon-14 level starts to decrease. Okay? It starts to turn into nitrogen-14. So, yeah. Okay? So, eventually, based on the nitrogen-14 concentration, okay, scientists can actually measure that concentration, and due to the amount of it present in any kind of organic material, scientists can actually kind of work backwards to figure out how much or how long it's been since that organism was living. Okay. You can also, because your carbon-14 concentration remains constant, okay, that is based on the size of the organism, the living organism. Okay, because if you have a larger organism, you have more carbon in that organism, so you have more carbon-14. Okay, so based on the size of the organism, scientists can actually calculate how much carbon-14 the organism had while it was living. Okay, and then they can measure how much there is left in the organism when they find it, okay, in the remains that they find. And through that, they can figure out, okay, it's gone through this many half-lives, which means it's roughly this old. Okay? So that's how carbon-14 dating works. Obviously not 2 carbons going on a date, but I still think that's a really cute little drawing. So anyway, that is it for this section.